On your notes, please, write down your objective for today, your know and do. Our know today is to factor the difference of two squares, and that is found in section 8.5 in the Algebra 2. So let's go ahead and let me just put that little note here for that. That's going to be in section 8.5 in your textbook. And then we're going to factor the sum and difference of two cubes. And by the way, this is in Algebra 1. And this one here is going to be in section 6.4, and it's going to be found in Algebra 2. So today you're going to need, I have a handout for you for section 8.5 Algebra 1. And guest teacher, that is found over there on the table besides my desk. And then the students are going to be using section 6.4 in your Algebra 2 textbook for that assignment. All right, so guest teacher, go ahead and pause it for a second while they write down the know and do. Okay, now that you have the know and do down, let's go ahead and quickly go to the lesson here. Let's quickly take a look at this activity. As you take a look at this activity, we're going to just identify some perfect squares. So let's identify what a perfect square is. If I say a perfect square, I'm talking about a number times itself giving you something like 64. Well, we know the perfect square of 64 is 8. Okay? So 64 is called a perfect square. Now, is 45 a perfect square? Well, no, it isn't, because something times something is not 45. Now, another way you could do it is you could take your calculator, go to the square root of 45, and does it give you an integer? And since it does not, then it's not a perfect square. Let's go over here to 36. Is 36 a perfect square? Is it?
Yes.
Yes, it is. Very good. Because 6 times 6 is 36. What about x squared? Is x squared a perfect square? Is there something times itself that equals x squared?
Yes.
Yeah, 1x times 1x is, so x squared is a perfect square. Now what about y to the 8th? Is something times itself y to the 8?
No.
Okay, I hear no, I hear some yeses.
Y to the fourth.
Y to the 4th, yeah. Y to the 4th times y to the 4th is y to the 8th.
And somebody told me no, that was wrong.
Okay, all right. What about 4x to the 6th? 4x to this. Well, look at the 4 part. Is something times something 4?
Yes.
Yeah, 2 times 2. Is something to a power times something to a power a 6?
Yeah.
Yes. Matter of fact, here's the key. If the exponent is even, then it is. For example, how about x to the 3rd, x to the 3rd? Because 3 plus 3 is 6, right?
Yeah.
Okay, so this is yes, and our perfect square is going to be 2x to the 3rd. So really all you have to do is take half of this number. If 2 goes into the exponent, that's its perfect square. Notice this one. Did 2 go into 8?
Yes.
A 4, so it was y to the 4th. Okay, now look at this one. You have a 9. Now, is 9 a perfect square?
Yes.
Yes, it is. But does 2 go into 7 evenly? No, which means it is not a perfect square because both of them have to be a perfect square for the term to be a perfect square. Now, let's look at this one. 49p to the 10th is, yes, why?
Because 7 goes into 49 and then 5 goes into 10.
Very good. Very good. So it's going to be 5p to the 5th. So this is what a perfect square is all about. Okay, going on. Now, as a little preface activity, let's take this problem. And what I want to do is we're going to factor this, or FOIL it. When we FOIL it, remember you multiply first times first, and you get your x squared. Then you're going to multiply the x times the 3, and you're going to get a what? 3x. Then you're going to multiply the negative 3 times the x, and you will get negative 3x. And then you're going to multiply negative 3 times a positive 3, and that gives you a negative 9. Now notice what's going to happen. Your 3x minus your 3x, this is going to subtract out, leaving you with x squared minus what?
9.
Minus 9. Now, today we're going to go backwards with it. I want to go from this to that. Now, look up here or look down here and let me ask you, how many terms do you see right there?
2.
2. When there are 2 terms, we factor by a special case. When there are 2 terms like this, now notice here, does this term, is it a perfect square?
Yes.
Yeah, x squared is a perfect square. Look at this term. Is that a perfect square? 9? You bet. So when this term is a perfect square and this term is a perfect square and there's a subtraction between it, I'm going to use a formula to factor it. Okay, so let's go ahead and take a look at what that formula is. Now, I know there's a lot of wording in here, but I'm going to underline the important parts here. In your notes, I want you to put the words difference of 2 squares. And then after difference of 2 squares, I want you to write a formula. That formula is going to be this. A squared minus b squared is equal to, so put an equal to sign there, the quantity a plus b times the quantity a minus b. Okay, guest teacher, you might want to pause it for a second while the students get these notes. All right, let's take a look at just how easy it is to factor something that is a difference of 2 squares. So let's take a look at this problem. I have 4x squared. Is 4x squared a perfect square?
Yes.
Yes, it is, because 2 squared is 4, and x times x is x squared. Okay, so the perfect square here is going to be 2x times 2x. Okay, now, what about the perfect square of 9? 3 times 3. Very good. Okay, so I have a difference of 2 squares here. I have a difference of 2 squares. So because I have a difference of 2 squares, we're going to go ahead and factor it. Okay, let's go to the next slide. Okay, the question is, before we go on, what if they're not a perfect square? If they're not a perfect square, a difference of 2 squares, then you don't use special cases up above. It'll be either one of 2 things. Either you'll ask yourself, is there a common factor? And you'll factor that out. Or it'll be prime. Okay, one of those 2 things. All right, let's take a look at this problem here. And Group 2, Student 3. Okay, all right. Going on here, here's my formula. A squared minus b squared is equal to a plus a b times a minus a b. Okay, so here's what we're going to do. Look here, and what was my a value? My a value on this problem was a what? It was actually x. It looks like this. X squared minus 3 squared. Okay? Minus a 3 squared. So if I look at the formula here, my a value, this is my a value. So my a value is the x, and this is my b value here. My b value is the 3. So all I do is I'm going to put x in this formula every place I see an a, and I'm going to put b every place I see a b into that formula. And voila, it's factored. That's as simple as it is. Okay, let's go on. Let's try another problem. Here's my next problem. 3p squared minus 9p to the 4. First of all, ask yourself right now, the way this sits, can you do this as a difference of 2 squares? And if not, explain why. Look at the first term as a hint. What do you see there? 3. Is 3 a perfect square? No. Is 9 a perfect square?
Yes.
Is q to the 4th a perfect square?
Yes.
Yes. But because 3 is not, that means, and group 1, person 3, that answered your question. Since one of them is not, it's not a perfect square, so that means you cannot factor it as a difference of 2 squares. So there's the situation of what happens when one of them is not. So what do you write? Well, you just write you cannot factor it as a perfect square. In other words, It's prime. For now. And let me verify that. It's prime for now, but some of you might have realized something. And I see a hand up over here to my right. What do you see?
No, it's not that, but I'm saying, okay, so if it was like this, we would just say it's prime?
For today, yes.
Okay.
But actually, later on, when we put all the different steps together, it's not going to be prime. And here's why it's not going to be prime later. It's prime as far as perfect squares. If you look at these two terms, do you see something common to those two terms?
C. 3.
A 3, yes. Later on, you can factor out a 3. So later on, you'll factor out a 3, and you'll be left with p to the second minus a 3q to the fourth. So later on, when we combine all the different ways, together, this will be your answer. But for tonight, you'll just put prime. Okay, for tonight, just put prime. Okay, let's go to another problem to practice. Okay, here's our next problem. We're factoring this. Ask yourself, is 100x squared a perfect square?
Yes.
Okay, what are the perfect squares? 10x. Very good. So 10x and 10x. Is 4y squared a perfect square? Yes. Yeah. Yep. 2y and 2y. Very good. So notice you see that your a value, what is my a value here? 10x. And what is my b value? 2y. Good. So you could write it like this if you chose. Do you have to show this step? No, you don't. But sometimes it's helpful to do that. So when you factor it, you're just going to plug it into this formula like I showed here. You're going to plug 10x into every place you see an a, and you're going to plug a 2y into every place you see a b. So when you're all done, it looks like that. So the factoring of this problem, this is your final answer right there. 10x plus 2y and 10x minus 2y. Just as a note, some of you probably looked at this and you're going to say, it looks to me like there's a greatest common factor in this form. So later we'll factor it further, but as far as for today, this is all you have to go. This is all the farther you have to go with it. All right, let's go ahead and do another problem here. Everybody got that down now? Okay, if not, guest teacher, go ahead and pause it for a moment. If they have it all down, we'll just go on to the next slide. Okay, now let's try this one. We're going to walk through one more together, and then I'm going to have you guys start walking through some by yourself. All right, so looking at this first one, what is the perfect square of x to the fourth? X to the what? Second. Okay, so I'm going to put x to the second, and I'm going to put parentheses around that, because I know that x to the second squared is x to the fourth. Okay, and on the next one, this one here, what is the perfect square of 25y to the sixth?
25y cubed.
Almost.
5y
5y cubed. Okay, so we're going to go this, and it's going to be squared. Now, what is the sign between these two terms? It's a minus, isn't it? Do I have a difference? Minus means difference of two squares? Yes. So since I do, what is my a value? Let's identify what is my a value. It is x to the
squared.
second power. And then what is my b value? 5y to the third. Very good. So now I'm going to use this formula that says a squared minus b squared is equal to a plus a b, a minus a b. And so now let's just plug stuff in there. Every place I see an a, I plug an x squared. So I'm going to plug an x squared there. And I'm going to plug an x squared here. And I'm going to plug a 5y cubed, so plus a 5y to the third power there, and a minus 5y to the third power there. And now I factored it. Now I've factored it. By the way, at this point, if we stick with what we've been doing the last couple days, we probably should check it. So if we check it and we FOIL it, it's going to give us x to the fourth minus 5x squared y to the third plus a 5x squared y to the third minus a 25 y to the sixth. These two here subtract out, and I'm left with x to the fourth minus 25 y to the sixth. Is that what I originally started with up here?
Yes.
Okay, so it checks, and that tells me that this right here is my answer. Okay, let's get you guys started on a couple of these. So, using your shoulder partners, and guest teacher, I'm going to pause it at this point, but using your shoulder partners, let's do this one, and we'll come back to it here in a moment or two. Okay, we've taken a second to do this. Let's go ahead and work this through. There was a question before asked by one of the students. Is it okay if we can see what our A value is, and if I can see that what my B value is, can I just write it into the formula? In other words, can I take this, and if I can just see it, can I just put 1 plus 2x, and then 1 minus 2x? If I can just see it, can I just write it like that? And the answer is yes, you can. And once you write it like that, then you need to show the check. So go ahead and multiply it so you get 1 minus 2x plus 2x minus 4x squared, and that'll give you 1. These two here will subtract out, minus 4x, and that's what we started with, so it checks, and there's your answer. So it's perfectly okay to, if you can see it, just write it down. Now, another question was asked here, or let me ask this question here. Is this the same as going 1 minus 2x and then 1 plus 2x? And the answer is yes. It is the same because of what property? Community property of multiplication. That is correct. Okay, let's go to another question. We're going to do one more of these, and then we're going to go on to sum and difference of two cubes. Okay, with your shoulder partners, go ahead and try this problem. Guest teacher, go ahead and pause it. Okay, let's go ahead and take a look at this problem again here. Now, we had a question, before I go on here, we had a question that was asked, and the question was, what if this were a plus? How would that be different? I do not have the sum of two squares. We only have a difference of two square formula. So if it says sum of two squares, in other words, if this is a plus right there, your answer would just be the word prime, because you cannot factor it. Okay, working on this one, I can look at this, and my difference of two squares is p to the 8, a difference of two squares. Is it?
Yes.
Yes, because 8 can be divided by 2, so it's going to be p to the 4th, so I'm going to put a p to the 4th here, and a p to the 4th there. Then it's going to be 1 plus and 1 minus. Now, is 49 a perfect square?
Yes.
Yes. So is q to the 6 a perfect square?
Yes.
Yes, it is again. What is it? Q to the what? Third. So it's going to be 7q to the third. So 7q to the third. Okay. And then, of course, we're going to check it. And when we check it, you're going to get p to the 8th minus 7 p to the 4th q to the third plus 7 p to the 4th q to the third, and then minus 49 q to the 6th. So that gives us p to the 8th minus 49 q to the 6th, and that checks. So there's our answer. Okay, thumb quiz real quickly. How many of you are thumbs up and you're ready to go on? Okay, everybody here looks like they're good. Guest teacher, if not everybody is good on your end, go ahead and walk through these next two problems, and you can pause it as needed. So I'm going to do this one here, or I'm going to just kind of, I'm not going to do it, but I'm going to show them so you can show the class. Feel free to pause after each one as needed. Okay, on this one here, if the class needs it, you can walk through this little quiz. I don't think my group is okay here, so I'm going to just slide right on by. But if you're in, or if you're curious, hopefully you can just quickly see what these are. And that uncovers the answer to each of one of these. Now, our time is kind of running low. We're down to 15 minutes here, so we probably should get to the next set. The homework on section 8.5 is going to be 8 to 13, and then 21 to 26, 33, and 35. Guest teacher, if you'll pause it at this moment and hand out the worksheet. If you have more than probably about 20 minutes left, go ahead and have the students work on this for a little bit of time. If not, begin the next lesson immediately. Okay, go ahead and pause it at this time. Okay, let's go ahead and go on. So far, you have had section 8.5. Your teacher has handed you out the worksheet for section 8.5, and you're going to be doing these problems. Okay, let's go to section 6.4 of our Algebra 2 book. We are now done with our little substitution piece of factoring from the Algebra 1. Now we're ready to get back into the Algebra 2 book. So as we look here at the Algebra 2 book, let's go ahead and we're going to learn two more formulas. And these are called sum of two cubes and difference of two cubes. Okay, guest teacher, go ahead and pause it for a moment while the students write down the sum and difference of two cubes formula. And while they're writing that down, there's a handout over on the table that I'd like you to give to the students. And that handout is just called formula handout. So go ahead and hand them that handout, please. Go ahead and pause it. Okay, now that you have those formulas written down, let's take a look at the sheet that I just gave you. Here's the sheet that you should have in front of you. Now let's kind of point out some things on this sheet that's important. We need to talk about two cubes. What is a cube? Well, an example of a cube, for example, if I were to give you a 1. So let's underline the 1 here. What is the cube of 1? Well, it's what times what is 1? Well, 1 is, right? 1 cubed is 1. Well, what times what is 8? Well, how about 2 times 2 times 2? That's 8. So 8 is a perfect cube because 2 cubed is 8. Well, what's another cube? Well, think with me in a second. Let's just go down the numbers, the whole numbers. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed 125, good, and you can just keep going just like that. So all these are cubes, okay? So 3 cubed, 4 cubed, okay, those are cubes. Now what we're going to do now is we're going to use these two formulas right here, and we're going to plug stuff in. But first of all, we have to see if it's a cube. Now, if you take your calculator and you look for the cube root button on your calculator, that'll help you. So you can plug in a number and then just hit the cube root button and see if it gives you a whole number. If it does, then it's a cube root. Now, there's a little saying that helps you. The word sofas here is a mnemonic device to help you memorize this pattern. Now, go down a little bit here and let's take a look at this little chart. The S stands for square of the front. The O stands for opposite signs. The F means front times back. The A means always positive. The S means square of the back. And of course, then you have your A, your answer. And I look here and I see that I'm running out of time quickly here. So let's use this and we're going to go on. Okay, so let me jump straight ahead. By the way, if you see this little chart, this kind of shows you where each thing is. Okay, so let's go ahead and go to our next problem and let's uncover this. First of all, 125, is it a perfect cube? Yes, it is. 5D. Okay, so we'll put it right there. And then 8, is it a perfect cube? Yes, it is. 2. Okay, so I can see that my A value is a 5D and my B value is a 3. So all I have to do is put 5D in for the A and 2 in for my B into my formula, and I have it factored. It's done. That's all there is to this whole process. Now, you could clean it up a little bit because you see how you have the 5D times 2, and then you see the 2 squared. So you can clean it up a little bit, and you'll get that for your answer. And by the way, this is done. It cannot be factored anymore. That is your answer. And you just do it by formula, by plugging it in. Okay, let's go to another. Since we're running low on time, I'm going to slide straight ahead to the next problem. Here you have this problem. So first of all, let's identify the A value. What is your A? What is 8 cubed, or cube root of 8? 2. And what is the cube root of z to the 6? Well, divide it by 3. You know, just like we did with the perfect square, we divided it by 2. This time, divide it by 3. So that means your B value is what? Z to the 2nd. So now because it's a plus, we're going to use this formula right down here. So just plug it in. So it's going to be 2 plus z squared times, and you're going to have a 2 squared minus a 2 times z squared plus, and then you're going to put a z squared squared. Now clean it up. So it's going to be 2 plus z squared, and then it's going to be a 4 minus 2z to the 2nd power plus a z to the 4th power, and you're done. That's all you got to do. Now, isn't that easy? I hope it's very easy. Anyway, just plug it in. Identify the cubes and plug it in. Okay, there's your homework for tonight. And you know what? This right here, it says quiz next time. You know what? Let's not take a quiz next time because I want to review for a test next time. So, right here, let's knock this out because next time I'm going to give you a review sheet. Next class period, I'll give you a review sheet, and we're going to be reviewing for a test. So that'll be what is happening next class period. Okay, if there's time permitted in the group, let's go ahead and work on these problems. Have a good day. Thank you very much, and goodbye.